Had you have my heart? All you're looking for is me. Can't tell me what you need. Boy, you know just who you are. Hold my hand, don't go too far. All you're looking for is me. Can't tell me what you need. What you babe, 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 what you need, babe, babe. Tell me what you need, babe, 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 what you need, what you need.
I don't know who's Margot.
Land use, natural resources, and energy. Land use is a term used to describe the human use of land. It represents the economic and cultural activities that are practiced at a given place. Public and private lands frequently represent very different uses. For example, urban development seldom occurs in publicly owned land, while privately owned lands are infrequently protected for wilderness uses. Effects of land use changes. Land use changes occur constantly and at many scales and can have specific and cumulative effects on air and water quality, watershed function, generation of waste, extent and quality of wildlife habitat, climate, and human health. Land development. Land development creates impervious surfaces through construction of roads, parking lots, and other structures. Impervious surfaces first contribute to non-point source water pollution by limiting the capacity of soils to filter runoff. Next, affect peak flow and water volume, which heighten erosion potential and affect habitat and water quality. Affect groundwater aquifer recharge. Point source discharges from industrial and municipal waste water treatment facilities can contribute toxic compounds and heated water. Land development can lead to the formation of heat islands, domes of warmer air over urban and suburban areas that are caused by the loss of trees, shrubs, and the absorption of more heat by pavement, buildings, and other sources. Heat islands can affect local, regional, and global climate as well as air quality. One of the example use of land is the agricultural uses. Agricultural land uses can affect the quality of water and watersheds, including the types of crops planted, tillage practices, and various irrigation practices can limit the amount of water available for other uses. Livestock grazing in riparian zones can change landscape conditions by reducing stream bank vegetation and increasing water temperatures, sedimentations, and nutrient levels. Runoff from pesticides, fertilizers, and nutrients from animal manure can also degrade water quality. Agricultural land use may also result in loss of native habitats or increased wind erosion, and thus exposing humans to particulate matter and various chemicals. Some land uses can accelerate or exacerbate the spread of invasive species. In some cases, changes in land use may have positive effects, such as increasing habitat as a result of deliberate habitat restoration measures and reclamation of previously contaminated lands for urban or suburban development. The natural resources. Resources obtained from nature, from the earth, are called natural resources. These resources occur naturally and humans cannot make them. The raw materials used in artificial or man-made resources are natural resources. Classification of natural resources. Classification of natural resources can be done in several ways based on their origin, level of development and uses, stock or deposits, and their distribution. On the basis of their origin, natural resources can be classified into living or biotic and non-living or abiotic resources. Living or biotic resources. If natural resources come from living things or organic materials, they are termed as living or biotic resources. Biotic resources include plants, animals, fossil fuels such as coal, oil, and natural gas are classified as biotic resources as they are formed from the decay of organic matter over millions of years. Next is the non-living or abiotic resources. On the other hand, if the resources are derived from non-living and organic materials, they are termed as abiotic resources. For instance, air, sunlight, and water are abiotic natural resources. Minerals are also considered abiotic. On the basis of deposit or stock, natural resources can be classified as renewable and non-renewable. Let's talk about renewable natural resources. Resources that can be used without any risk of its ending up are called renewable energy. They exist in unlimited quantity. Sun, water, wind, biomass, tides, geothermal energy, etc. are renewable energy. These are infinite sources of energy. So let me show you a renewable resources example: solar energy, water, and wind. The non-renewable natural resources. Those natural resources, on the other hand, cannot be replenished after the depletion is called non-renewable resources. Most fossil fuels such as coal, petroleum, and natural gas are considered non-renewable resources. Let me show you some examples of non-renewable natural resources: the oil, natural gas, and crude. Non-renewable resources take billions of years for their formation, hence their cautious and economic use is the only option left for mankind. On the basis of development of resources, natural resources can be classified as actual and potential resources. Actual resources are those resources whose quantity is known. These resources are being used in the present. Examples: rich deposit of coal in Germany, petroleum in West Asia, and dark soil of the Deccan Plateau in Maharashtra. Next is the potential resources, are those whose entire quantity may not be known, and these are not being used at present. This recourse could be used in the future. The level of technology we have at present may not be advanced enough to easily utilize these resources. Examples: uranium in Ladakh and high-speed winds. Now let's talk about what is energy. Energy has always been closely linked to man's economic growth and development. Present strategies for development that have focused on rapid economic growth have used energy utilization as an index of economic development. This index, however, does not take into account the long-term ill effects on the society of excessive energy utilization. Industrialization, urbanization, and unbelievable rise in human settlements have multiplied the energy requirement by several times. Renewable energy resources. Renewable energy systems use resources that are constantly replaced and are usually less polluting. Examples include hydropower, solar wind, and geothermal. We also get renewable energy from burning trees and even garbage as fuel and processing other plants into biofuel. Next is the wind energy. The moving air or wind has huge amounts of kinetic energy, and it can be transferred into electrical energy using wind turbines. The wind moves the blades, which spins a shaft which is further connected to a generator. An average wind speed of 14 miles per hour needed to convert wind energy into electricity. Wind-generated electricity meet nearly 4% of global electricity demand. Solar energy is the light and heat procured from the sun. It is harnessed using an ever-evolving technologies. In 2014, global solar generation was 186 terawatt-hours, slightly less than 1% of the world's total grid electricity. Italy has the largest proportion of solar electricity in the world, in the opinion of International Energy Agency. The development of affordable, inexhaustible, and clean solar energy technologies will have longer-term benefits. Biomass energy. When a log is burned, we are using biomass energy, as the plants and trees depend on the sunlight to grow. Biomass energy is a form of stored solar energy. Although wood is the largest source of biomass energy, agricultural waste, sugarcane waste, and other farm byproducts are also used to produce energy. Hydropower. Energy produced from water is called hydropower. Hydroelectric power stations, both big and small, are set up to produce electricity in many parts of the world. Hydropower is produced in 150 countries, with the Asia-Pacific region generating 32% of global hydropower in 2010. In 2015, hydropower generated 16.6% of the world's total electricity and 70% of all renewable electricity. Geothermal energy. It is the energy stored within the earth. Geo for the earth and thermal for heat. Geothermal energy starts with hot, molten rock called magma, deep inside the earth, which surfaces at some parts of the earth's crust. The heat rising from the magma warms the underground pools of water known as geothermal reservoir. If there is an opening, hot underground water comes to the surface and forms hot springs, or it may boil to form geysers. With modern technology, wells are drilled deep down the surface of the earth to tap into geothermal reservoir. This is called direct use of geothermal energy, and it provides a steady stream of hot water that is pumped to the earth's surface. So, we must utilize our land, natural resources, and energy properly in order for us to live abundantly. Thank you.